Hello, hello. Hi. Hello, everybody. Yeah, good morning, almost afternoon. Thank you all so much for being here. My name is Patty Chow, and I will be joined later by Khelan Modi. We're both product managers at Azure DocumentDB. And later, we're also going to be joined by Gurvinder Singh, a principal cloud engineer at the Kraft Heinz company. So our agenda is pretty simple. We'll start off with an overview of DocumentDB, which is our open source engine. Later, we will announce Azure DocumentDB, which was formerly Azure Cosmos DB for MongoDB core. We're going to talk a little bit more about that. Then we'll show you how you can migrate seamlessly your MongoDB workloads to Azure DocumentDB before handing it off to Kraft Heinz to talk about their solution. And lastly, we're going to talk about what's next in multi-cloud. Cool. Oh, thank you, everybody. Wow. Yeah. Yeah. Well, before we dive any deeper, I do want to kind of zoom out and talk a little bit about the landscape of data. It is changing rapidly. Today, over 70% of enterprises run their workloads across 2 or more clouds, and open source has been growing rapidly. And this shows you that teams want choice in what they do. They want flexibility and they want transparency. And with AI moving so quickly, data needs to be portable, queryable, and real-time, no matter where it lives. So DocumentDB really was built for this new era. But what is it? It is an open source MongoDB-compatible database engine, and it allows you to run your MongoDB workloads almost anywhere, starting locally using Docker. But when you're ready to move into the cloud, we're going to show you how you can migrate to Azure DocumentDB with a click. And that's not the whole story. You can create multi-cloud solutions using AWS, GCP, and other major cloud providers when you're ready for a multi-cloud or a hybrid cloud solution. But DocumentDB is not just a Microsoft project. It is really a community project. We've recently donated to the Linux Foundation, and the industry momentum behind it has been nothing but incredible. As you can see, we have a lot of great supporters and partners, and what this tells us is really simple. The industry is starting to align with an open, portable, NoSQL standard, and that's something that we're moving towards. But for you, that means that you will get more choice in where you deploy, more flexibility, and more long-term stability. So if you're interested in getting started, you feel free to scan our QR code. It'll take you directly to our GitHub repo. And there you can deploy locally using Docker. And if you're using VS Code, you can use our VS Code extension, which Khelan will talk to you a little bit more about.
Thanks, Patty. So with DocumentDB, we're trying to make it easier for you to get started with it. So we have one-click connectivity to DocumentDB or any MongoDB cluster with our VS Code extension. You can quickly import, export your data to streamline all data movements, along with to view your data in JSON, tree view, or table view. We're also bringing a new functionality to our DocumentDB VS Code, which is the first ever LLM-based index advisor for DocumentDB. Ooh. What it does is it analyzes your workload and your query patterns and sends it to an LLM to give you a personalized index recommendation. So no more reading documentation or asking ChatGPT for the best indexing policies. I do have a demo for you, so let me do it right now real quick. Over here, I have an Azure DocumentDB cluster with over 100,000 documents. It is named as TestDB and Test Collection. And I'm going to ask, and the data is stored as age, city, name, and score. I'm going to generate a simple find query to give me data points with city equals Chennai. All right. Now, it was able to generate a query using just natural language. Let's run this query to find the document with city equals Chennai. And you can see we have all the documents with the filter that was Chennai. Let's look at the query performance of this query. As you can see, it took over 25 milliseconds to run this query. We did a collection scan of 99,950 documents and it only returned 14,319, which is not optimal if you think about it. You don't want to do a full collection scan to just return 14,000 documents. So we can optimize it with AI. And how it works is you just click on Get AI Performance Insights, and what happens is we are sending sanitized data back to LLM, which is GitHub Copilot running in this instance with GPT-5. And we don't store any customer data or any of your query data anywhere in a database. We just send the sanitize function to give us the performance, insights, and recommendation on how you can make it better. All right, as you can see, it was able to tell us the query performance is poor because we did a full collection scan, reading 99,000 documents to return only 14,000, which is a relevancy of 14.3%, indicating wasted work. We also highlights the key issues, what the problems are, and how you can make it better. We also added a card for you to make it, how to optimize your performance, but just create an index on the field city. So let me click on Create Index. And it just created an index on the city field. Let's go look at our database under indexes. If I hit refresh, it's going to list the city index over there. Now, let's run the same query again to look at the performance difference. And as you can see, it reduced from 24 milliseconds to 4.69 milliseconds. And it only examined only 14,300 documents, the optimal amount that we need for optimal performance for our database. So moving on, we are bringing the same functionality to our Azure service. How many of you know over here vCore-based Azure Cosmos DB for MongoDB? Has anyone heard of it? Again, we're just changing the name to Azure DocumentDB, and we're bringing all the same functionalities for DocumentDB to our Azure service. So you get 99.03 MongoDB-compatible commands. It's built on the same open source engine as DocumentDB, so you can run anywhere. It is AI ready, so we best-in-class vector search powered by Microsoft proprietary disk KNN, which is used by a lot of our customers, including Kraft Heinz, EY, KPMG, and a lot. We also have hybrid search and full text search capabilities in Azure DocumentDB, and we give you up to 99.995 SLAs across your full service stack. And additionally, it's cost effective. We give you up to 45% cheaper than any other MongoDB-compatible workloads out there, with 35 days of backup and 24/7 support included. You can get started today for free with a 32 gig storage with Azure on the Azure portal. And this is why it is a great source for migration. We give you one-click assessment, which supports online and real-time transfer and offline for planned downtime migration. You can do the migration through our VS Code app, MongoDump, MongoRestore, or the web app. Let me quickly go over how the migration works in our VS Code extension. Over here, I have an on-prem MongoDB cluster with a bunch of collections and a bunch of database. I'm going to click on our DocumentDB for VS Code extension and run a simple data migration from on-prem to the cloud. We migrate to Azure DocumentDB. You can either do a pre-assessment where it gives you a comprehensive assessment of how compatible Azure DocumentDB is with your workload and what the best way to migrate the data is. Or you can click on Migrate to Azure DocumentDB. Oh. So the whole process should take you around 10 minutes for the migration based on how big your workload is. This is the video again. And once you click on Migrate to DocumentDB, you need to give a job name for your migration. You can either perform an offline or online migration based on how your workloads perform, or you can also do a connectivity between public and private. To get started, you need to target your Azure DocumentDB account with the subscription and the resource group where the DocumentDB cluster lives. And finally, you need to add the account name where you want to transfer all your data to the cluster that is under Azure DocumentDB. So I'm going to select build 25 over here and provide the connection string to that Azure DocumentDB cluster. And then I'm going to hit next. And I'm going to set up a DMS service, which is going to automate the whole migration job for us behind the scenes. And I'm going to select the collection and the database I want to migrate from on-prem to Azure DocumentDB. I'm going to search for sample restaurants because that's the name of my database. And I'm going to copy all the collections from that database over. You can either choose to migrate all your data and indexes or just the data based on how you want to perform it, how you want to migrate to Azure DocumentDB. And you can then start migration, and it's going to start the migration behind the scenes for you. You can also look at all the existing migration jobs that you have available, so you can do multiple migrations at once. So for this demo purposes, I skipped to the end, which usually takes around 10 minutes and 14 seconds to do a bulk copy from your on-prem to Azure DocumentDB cluster. So as you can see, it was able to complete and transfer over 35,000 documents with the time it took to transfer everything. The next step is I'm going to open my Azure DocumentDB cluster in my VS Code extension and click refresh. And you can see sample restaurant collection has been copied over from your on-prem to the cloud with all the collections that we selected, along with the indexes that were already assigned in the on-prem cluster. So it's that simple. And it's just everything is integrated with VS Code, so you don't need to download any more services or anything else. Everything is right there for your data access and data movement in the VS Code extension. And did I mention that it's AI ready? We are bringing our LLM-based index advisor to Azure DocumentDB. And not just that, we do have this KNN, which Kraft is going to talk about in a second, of how we're able to scale the production workloads to billions and millions of users out there. We also support up to 16,000 dimensions. So for context, the largest embedding model out there is over 4,096 dimensions. So we support up to 16,000. So if OpenAI or Claude or Meta comes up with a new model, we'll still be able to be compatible with those models. So I have a quiz for you. I've been yapping for the last 10 minutes. So how can you run Index Advisor? Is it only DocumentDB? Is it Azure DocumentDB only? Is it DocumentDB and Azure DocumentDB only? Or does it work on all MongoDB-compatible workloads? If you think it's 1, raise your hand. OK. If it's 2, if it's 3, OK, I got a few hands. And if it's 4, all right, you guys are all correct. It's actually all MongoDB-compatible workloads work for our index-based LLM-based index advisor. So you don't need to be you just need to download our DocumentDB for VS Code extension, and you'll be able to optimize your database performance with our index advisor. And also today, we're announcing advanced full text search in Azure DocumentDB. So what this means is if anyone has an Elasticsearch workload, they don't need to have a separate dedicated service for that. We're bringing all the functionalities of Elasticsearch to Azure DocumentDB. What this means is now you can perform fuzzy search, which is basically if you do a typo in your search query, fuzzy search is able to understand it's a typo and still find you relevant documents based on the query that you just inserted. We're also bringing proximity search, adding more language support as Chinese and Thai. And then we are bringing the best ever rank fusion, which combines your text searches and vector searches with just one command. So no more doing text search, vector search, and ranking it again. We just bring all of it together. So it makes it easier for you to run your hybrid searches with any MongoDB-compatible workloads. And this is why Tata Digital recently migrated their Tata new application to Azure DocumentDB. So they have over 110 million active users, and they perform 600,000 vector searches every single day. And the reason for them to choose Azure DocumentDB is because we had dependable performance, we had predictable cost, and we have integration with all Azure services. Since Azure DocumentDB is an Azure first service, we integrate with all the Azure services at the easiest way possible. So they were able to do a simple migration to Azure DocumentDB with our VS Code extension and bring over all the workloads over here at ease. And speaking of customers, we have a special guest today from Kraft Heinz, Gurvinder Singh. He's going to talk about why they chose Azure DocumentDB for the AI workloads, and he's going to give us the whole process and how the application works. Thank you. Over to you, Gurvinder.
Thank you, Khelan. So good afternoon, everyone. I'm Gurvinder Singh, Principal Cloud Engineer at Kraft Heinz. So what you will see in the next 15 minutes is our journey from third-party graph database to Azure DocumentDB, which is 1400x faster, saves us significant amount of cost. And more importantly, the solution that we built here, it enables every user across enterprise, not just developers, right? So this is all about innovation and our partnership with Microsoft that helped us come to this solution and then make this the Cosmos AI graph solution that I'm going to talk about really end-to-end enterprise data lineage solutions. Okay. So before I dive in, let's understand why data lineage is critical for large-scale enterprises like us, right? So imagine you are driving in an unfamiliar city, so without GPS, what happens? Every turn is uncertain. So every wrong direction would cost you time, and you don't have a way to backtrack and things like that, right? So managing data without data lineage feels like the same. So we knew that importance, right? So the data lineage basically helps you maintain data quality, compliance, and governance in many ways. So knowing that importance, what we built in our first iteration, we chose third-party graph database, and that was our first data lineage solution in Kraft Heinz. So it paid off really well. Basically, we have many big wins. Some of those are listed here. So our developers were able to quickly identify the root cause when there were problems in production. They were able to quickly pinpoint problems looking at graphs and things like that. So especially when you're dealing with dozens of upstream and downstream interconnected systems, if you're making a change in one database table or whatnot, right? So you may wonder, what could be the downstream impact? So this is where data lineage helps, basically. So we were also able to eliminate hours of manual investigation work into minutes, right? So the solution paid off very well, but there were certain limitations that emerged over time. Some of those crucial ones are listed here. One, we are Azure first company. Most of our workloads run in Azure. So this database as a SaaS product was a separate island outside of Azure ecosystem. So we wanted to get rid of that because it was an operational overhead in many ways. Number two, the significant recurring licensing fees, annual fees, right? So we wanted to get rid of that as well. So we started off with a modernization imperative, right? So obviously, Azure native solution. So go Azure native. So this is where we chose Azure DocumentDB, working with Microsoft. We wanted to go one platform, one ecosystem. So that helped basically to minimize or remove the operational overhead. And then when you have one ecosystem, one platform, we have a seamless integration with other Azure services like, let's take an example, Microsoft Entra ID, that helps basically improve our security and compliance posture, right? So you can maintain the RBAC and everything in one platform, so across the database portfolios. Number two, cost and performance gains. So I'll deep dive into performance gains in our architecture side later on. So obviously, with our prior solution with third-party graph database, we didn't have flexibility to go pay-go model. There was no consumption-based pricing model available. It was upfront cost, annual cost, right? So with Azure DocumentDB, with vCore architecture, we had that flexibility, right? So our one problem was instantly solved, right? So, and last, AI-powered future, So this is where we didn't just migrate. We were able to unlock real innovation, so that I will double click into that later on. So here you go. So Cosmos AI Graph solution is the solution that we built. We call it Cosmos AI Graph solution. So, so this is one example where you can see, right, lots of interconnected system. So your developer would have visuals in front of them, and then they can zoom in, tap into a specific icon and look at metadata and find problems and things like that. They have full visibility, full insights here. So here's the architecture that we have, a Cosmos AI graph solution. Let me clarify one thing here. The Cosmos AI graph solution is not an Azure product as such. So this is basically a solution accelerator that combines set of Azure services that you see in this architecture diagram that enables us to kind of make this solution end-to-end data lineage at enterprise scale. So there are three main elements here. Number one, Azure DocumentDB. That's a persistent store for data lineage data, vector embedding, session store, and it has capabilities like Khelan talked about, vector search, hybrid search, full text search. All of these capabilities in one database platform, gives you very unified platform to simplify the whole architecture, right? So you're not dealing with separate databases for each of these capabilities. Number two, you see here, we have AKS cluster. We have two microservices hosted here. One is Graph microservice, and another one is a web microservice. It's a user interface for users to interact with the solution. So number three, Azure OpenAI with set of LLM models. This is where we unlock real innovation, right? So leveraging Azure DocumentDB, the vector search and hybrid search. So we'll go into that. So talking about the data lineage at enterprise scale. So you definitely need two capabilities, two fundamental capabilities. Number one, deterministic lineage, right? So ability to get an answer to a relationship answer to the question, consistent response basically to a relationship question. Number two, non-deterministic, basically semantic discovery, finding data sets by meaning, not just keywords, right? So we have this solution, the Cosmos AI graph solution, brings both capability to the table. So what we have here is we have dual pattern RAG architecture, which is different than the basic RAG. So we call the one is graph RAG and the other one is omni RAG pattern here, right? So the graph RAG service utilizes the graph RAG pattern utilizes the graph microservice here to load nodes and relationship data, entities, and everything into memory, and it utilizes basically triples and ontology to create knowledge graph basically. So what is triple and ontology basically? Let's talk about that a little bit. So the RDF technology here is RDF stands for Resource Description Framework. So it is a W3C standard to represent structured knowledge in three components: your subject, predicate, and object. So in CPG terminology, your subject could be customer's purchase table, predicate could be derived from, and then you have object, your SAP sales data. So the graph basically uses, stores that information, and these are three components. That's why these are called RDF triple. Now we define ontology, set of rules and specifications, that enable RDF framework to drive logical inferencing and semantic reasoning, right? So the graph service here, right? So responsible for graph generation, right? So leveraging everything in memory, it loads the raw data from Azure DocumentDB into memory, and it maintains, the ontology schema, and it knows, right, what to do next, right? So it creates the knowledge graph intelligently, right? So now the second, but one thing here, the RDF works very well for deterministic lineage, right, where facts are known. And for example, let's say if your prompt is like this, hey, show me what reports are impacted, what downstream reports are impacted if I make a change in this table, right? That's clearly a relationship traversal. You're looking for dependencies. So the graph RAG works here really well. But RDF would fail if your prompt is like this, hey, show me data sets similar to customer. You may have data set name as consumer. The customer and consumer, the underlying meaning is same, right? So you need a altogether different approach here. So you need a semantic discovery, right? So this is where the omni RAG pattern comes in. So omni RAG pattern here uses LLM models and semantic kernel to intelligently detect the intent of the user. If the intent is semantic discovery, semantic similarity search, it routes that request to Azure DocumentDB and things like that. If it is graph, and it routes to our graph microservice. Now, let's take an example, right? So 2 examples here. You are sending a prompt to this system. Hey, show me, if I make a change in this database column, what could be the downstream impact? So the pattern here, the OmniRag pattern detects, yeah, this is something relational traversal, right? So it detects and it generates Sparkle. RDF framework works with Sparkle language, and it sends this to graph service to generate graph. Now, the second example would be, hey, show me data sets similar to consumer PII that haven't been changed in the last 30 days or things like that, right? So you have 2 scenarios here. Number A, you're looking for customer. You may have data set named as consumer, so that requires a semantic discovery, right? And B scenario in your second example is you're looking for data set with PII, which is a keyword search. So both as these vector search and keyword search are powered by Azure DocumentDB. And then one thing is the vector search is really, the query response time is very quick and really responsive. I mean, we have seen those response time differences in our prior solution and this solution. So thanks to SSD bag, disk ANN indexing, basically that really enables Azure DocumentDB to work at, to make this, the semantic search at scale, right? So it was really a big win for us, a game-changing win. The second query, the example that I gave you, the OmniRag pattern basically detects that intent. It's a relational, it requires semantic discovery. It also requires a keyword search because you're looking for a customer. You may have consumer in the database names, things like that. So it basically sends this request to Azure DocumentDB. Azure DocumentDB here basically performs vector search using high dimensional vector embedding and keyword search using hybrid search mechanism, as Khelan was alluding to. So the hybrid search uses the reciprocal rank fusion to combine these 2 result sets. Basically, you're going to get two result sets, one vector and one keyword. So reciprocal rank fusion combines these 2 result sets, it dedupe them, and sends the comprehensive relevance back to OpenAI for completion. So if we were to just use RDF, it wouldn't be a complete end-to-end solution. So as I said, right, so at enterprise scale, you need deterministic and semantic discovery, and both of these capabilities are here in this solution, leveraging the dual pattern RAG architecture that I talked about. So yeah, so what we have built here is really a tech enabler architecture runway for our developers and engineers to taxi their innovation plane and continue innovating, right? So this was really a game changer for us, right? So thanks to Azure DocumentDB product team for amazing database, and I would also like to thank Kraft Heinz Microsoft account team for helping us get here, especially 𝗦𝗽𝗀𝗀𝗀𝗀𝗀 and Devin Jaswal, so for their amazing collaboration on this. Thank you very much, everyone. Back to you, Patty.
Thanks, Gurvinder. Yeah, that was an awesome presentation. I hope you learned a lot about the Cosmos AI graph solution. Something that I learned and that I appreciated was how integrated it really was with the Azure ecosystem as a whole. I mean, you saw some, or we saw some things in security that pertain to customer managed keys or Entra ID. I loved their use of Azure OpenAI and OmniRag, which was great. I also saw Azure Monitor. So really, that's the story that you get when you use Azure DocumentDB as a managed service in Azure. You get access to the whole ecosystem, but that's really not the whole story. Because Azure DocumentDB is open source, you're not just limited to Azure. So that's why we are proud to release and donate our own Kubernetes operator to the Linux Foundation. And this is great because it allows you to create both multi-cloud and hybrid cloud solutions just in different clouds or even on-prem. that means that Azure DocumentDB can become your primary environment, while the open source engine can run your collections and clusters in other clouds or databases when you really do need the flexibility. Let's see how that looks like in Azure, AWS, and GCP. Let's take a look.
Hello. In this demo, we will showcase multi-cloud functionality for Azure DocumentDB using the underlying open source engine coupled with the Kubernetes operator for the database, provisioned across Azure, AWS, and GCP. You can see here on the plugin that the state of it to start is that Azure DocumentDB is the primary and it replicates to GCP and AWS. The Azure primary is a fully managed DocumentDB service, while GCP and AWS are using Kubernetes with our open source database engine. There's one instance each for our replicas on AWS and GCP, while there are 3 instances on managed Azure. This setup ensures globally strong data consistency and local high availability. Using our VS Code extension for DocumentDB, we have on the left the 3 separate connections. Those each connect to the cluster individually on each cloud. But in our application, we use a global connection string, which points to the primary and automatically changes when a failover is triggered to point to the new primary region for the database. So right now, it'll point to Azure DocumentDB. But after we do our promotion later in the demo, that connection string will start pointing to AWS. We're inserting data into Azure DocumentDB, but I'm pulling up the collection on GCP, and you'll be able to see the records are being replicated to GCP and also to AWS. With our global strong consistency setup, any database insert operation made to the primary will only return a successful response to the client if the ingest data has been acknowledged by both the primary and at least one remote replica. This ensures that if the primary goes down, all writes confirmed by DocumentDB can reliably be assumed to be safe with absolutely no data loss. I'm going to pause for a moment now to allow some of the inserts to propagate to our data collection through Prometheus and Grafana so that we can view the chart. Now that that's done, you can see all the writes on Azure here in green, and we can now promote AWS to be our new primary. The promotion that we're doing here is a managed promotion. So the primary on Azure is first demoted, writes are all committed, and then the AWS replica is promoted to be the new primary. A similar process is triggered when a regional failover occurs, wherein the replica is promoted after we lose access to the primary, and data loss would still be prevented by our global strong guarantee. Now, I'll let this run for a while as well so that we can see the failover in the Grafana charts. As you can see here, because it was a managed failover, all pending writes are committed on Azure DocumentDB, so you get that lower level, and then our writes start to increase on AWS as the failover is over, seen in green. As you can see, there was only a small blip for the failover, and no application-side intervention was needed to restore availability on a different cloud. And there we have it, a globally distributed setup for Azure DocumentDB across 3 clouds with a quick, fully managed failover and 0 data loss.
Awesome. How cool was that? Yeah. So I hope that in this presentation you learned a little bit more about open source, our DocumentDB engine, a little bit more about our managed service, and how you can optimize your database both on-prem and in the cloud with our Kubernetes operator. If you're ready to get started, feel free to scan the QR code so you can try Azure DocumentDB for free. Or if you want to get started with open source, just scan that QR code or go to documentdb.io. And lastly, our VS Code extension is called DocumentDB for VS Code if you do want to get started. We have around 5 or so minutes to open up the floor for some Q&A. But if you have any other pending questions, we'll be in Moscow and South near Theater B. And the whole team will be there to answer any questions that you have. But again, thank you so much for coming. And yeah, let's open up the floor if anybody has any questions. We could use this microphone over here, or I think there's a microphone over here as well, if it works. Does anybody have any questions? Oh. Hopefully this works, yeah.
Test. Hi, great presentation though. Quick question, you mentioned something about the region failover scenario, some global storm or something like that. So can you elaborate a little bit more on that? Like how do you prevent the data loss or the availability with that?
Yeah, so I mean, because DocumentDB can be hosted across different clouds. It can also be hosted across different regions. And sometimes regions fail. And whenever, like the Kubernetes operator, when it detects that a region in and of itself is, or like the primary region itself is failing, it automatically uses, like replaces the backup as the primary. Does that make sense?
Yeah, so that
Okay.
happens automatically, or you have to do the manual intervention? That's my question.
I'm assuming it does automatically, but I'd love to get you connected with our engineering team so they can kind of explain that to you a little bit more in depth. Oh yeah, please.
I think what was demonstrated there that you can also set synchronous replication across regions. So when you commit to one region, you can also make sure it commits every write to every region for those writes that you select. It's not required. You can also do async, but now you can also do sync.
Yeah. I think there's a couple more questions over here at the front.
Hi, yeah, thanks for the great presentation. Really like the DocumentDB being a separate entity now, not to confuse with the broader Cosmos DB umbrella. I've got a question though about vector embeddings. Can you please give the key differentiators between Azure AI Search and Azure DocumentDB in that capacity?
Yeah, I think Khelan is our PM for vector search, so.
The question was about the differentiator between Azure AI Search and DocumentDB, right?
Yeah, that's
Again, the main reason, the main differentiator is DocumentDB is a database. AI Search is not a database. So if you want to extract your data for like multiple sources, like let's say Excel, PDF, Word doc, anything else, I would recommend using AI Search. But if you want everything to be stored under one umbrella, on one database, Azure DocumentDB is the solution for you.
okay, all right, thank you.
Yeah.
Any other questions? Come on.
Awesome. Well, I guess we can conclude here. And again, if you have any more questions, we are on Moscow and South near Theater B. And if, again, well, also, we also have our Azure Accelerate program where you can get access to trusted experts to start your journey migrating to Azure and Azure DocumentDB. So thank you so much for coming. Have a great rest of your Microsoft Ignite. Yeah.